Good day, grade 10 learners. Welcome to today's Physical Sciences lesson brought to you by the Gauteng Department of Education. My name is Bongani Mabuya and I will be with you throughout this lesson. We are still continuing with the electromagnetic radiation, but today we are going to focus on this term photon. That is the topic of the day. We are going to talk about photon. So the lesson objectives are: you should be in a position to indicate the penetrating ability of different kinds of electromagnetic radiation and relate it to energy of radiation. You should be in a position to describe and discuss the dangers of different types of electromagnetic radiation. And then you should be in a position to define photon. I think I have alluded to you that the topic of the day today, what is it that we are doing? We are going to define photon and we are going to calculate photon or using the photon equation. That is what we are going to do today. So that is the lesson of the day, photon. That is what we are going to talk about. So you need to make sure that by the end of this lesson, you know how to define photon. And you are in a position of calculating for what? Photon. That is what we are going to talk about. So I've simplified the lesson for the day. Know what is photon. So that is what we are going to do. We are going to define photon. And then relate photon to frequency, and also look at the relationship between the photon and the wavelength. And then use these fundamental equations, which are equations for photon. So it is very important for us to refer to the exam guideline in conjunction with the CAPS document. And this lesson, it has been taken from the exam guideline, page 12, and also the CAPS document, page 29 to page 31. So what is it that you already know? In grade 8, there was introduction of electromagnetic radiation. We spoke about that in grade 8. And then from our previous lessons, we've been talking about wavelength that is measured in meters. And we've been talking about frequency that is measured in hertz. And also we've been talking about electromagnetic radiation as a holistic content. So now I am going to give you 5 minutes to respond to these two fundamental questions so that I assess your cognitive and your actual development. 5 minutes. Now, I'm interested in your response to these two questions. Let's look at the first one. An electromagnetic radiation or wave. Remember, what did we say last week? We said that we are going to replace V with C when we deal with electromagnetic radiation. So we need to put that into cognizance as well. An electromagnetic wave has a wavelength of 200 nanometers. And we know that nano stands for times 10 to the power negative 9. So this is what we have. Let's write down our data. So we have the wavelength. We have the wavelength, which is 200 times 10 to the power negative 9 meters. So the question is asking us to calculate for frequency. So this is what the question wants. It wants us to determine the frequency of this electromagnetic wave. So we are going to use this formula. C is equals to frequency multiplied by lambda. This is what we are saying, that we replace V with a C when we deal with electromagnetic waves. So our C is a constant, which is 3 times 10 to the power 8, then equals 2. The question wants frequency. We don't know what is frequency, but we do know our wavelength. So our wavelength is 200 times 10 to the power negative 9. So remember, I always emphasize that with physics, this is how we get marks. Write down the correct formula. That is very important. Make sure that you write down the correct formula and then substitute correctly. If you have that, you have about 70% of that mark allocation. So it is important to stress the issue of writing down the correct formula. So grade 10s, write down the correct formula and fight to have a correct substitution. And then once you have it, then you see, I do not tamper with the substitution. Repeat it. 3 times 10 to the power 8, frequency, and 200 times 10 to the power negative 9. Then we solve for frequency. So we divide both sides by 200 times 10 to the power negative 9, 200 times 10 to the power negative 9. They cancel each other. Therefore, frequency is equal to. So let us go to the calculator. I'm also doing it with you so that you see from the calculator. Okay. So make sure that you come up with the correct one. And please WhatsApp us, of which our WhatsApp line is 064 748 8913. WhatsApp us and give us this answer. So we are more interested in you providing response to this answer. So I'm going to give you 1 minute just to punch in a calculator and then give me the correct answer. I do see that learners are requesting for more time. So they're saying that 1 minute is not enough. It's fine. I can lend you another extra minute. But I'm interested in this answer. and make sure that you also write down the correct units, because it is not enough to write the answer without units. So it is fundamental that you also do what? Write down the correct unit. So we can do this. So you are supposed to say 3 times 10 to the power 3 times 10 to the power 8, and then you must divide it by 200 times 10 to the power negative 9. So I'm still waiting for you on our WhatsApp line in 1 minute. And what is the correct answer? So the correct answer is 1,5 times 10 to the power 15 hertz. So it is important that when we write down the answer, we also put what? The units. Then let's look at number 2. Calculate the frequency of an electromagnetic wave with the wavelength. So now we are given the value of wavelength, which is 4,2 times 10 to the power negative 7. So we want the frequency again. So what do? We are given the wavelength, which is 4,2 times 10 to the power negative 7. The question wants what? The frequency. So you write down the formula. C is equals to frequency multiplied by lambda. And what is your C? It's a constant. It's a speed of light, which is 3 times 10 to the power 8. And we want the frequency, but we are given the wavelength, which is 4,2 times 10 to the power negative 7. You don't tamper with the substitution, because you get 1 mark for the formula and a mark for the correct substitution. So make it a point that you do not tamper with your substitution. Then you say 3 times 10 to the power 8, frequency 4,2 times 10 to the power negative 7. You solve for frequency. So you divide both sides by 4,2 times 10 to the power negative 7, 4,2 times 10 to the power negative 7. Therefore, what is your frequency? So you go to your calculator, 3 times 10 to the power 8 divided by 4,2 times 10 to the power negative 7. And then you are going to get 7,14 times 10 to the power 14 hertz, because the units for frequency are hertz. So I was assessing your actual development. What is it that you already know? So that is very important. That is very important. So as I've alluded to you, the topic of the day is photon. So that is the biggest question. What is a photon? What is photon? One thing that we know is that, yes, it is related to light, but what is photon? What is photon? So when we talk about photon, we are talking about packets of energy found in what? In light. That is what a photon is. It is the quantum of energy. That is photon. That is why we need the light, so that it can supply us with energy. We all know that the radiation from the sun provides us as living organisms with what? With energy. Where does this energy come? It comes as a photon, because photon is the energy in the light radiation. So when we talk about photon, we are talking about packets of energy in the light. That is very powerful. That is very powerful. So that is what the photon is. So you need to make sure that you sing this definition to your friends. You sing this definition to yourself. What is photon? It is the packet of energy found in light. Quantum of energy. That is what a photon is. Quantum of energy. And photon, it is measured in joules. So this is the symbol for photon, because photon is energy. So it is measured in joules. Photon, it is measured in joules. So it is the energy that is found within the light. So that is what we are talking about today. We are talking about photon. So make sure that you understand, you fully comprehend this meaning of photon, packet of energy. So it means that this energy comes in packets, 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 packets. So it is the packet of energy in light. That is a photon. So today, you must be happy that now you know that where does this energy come from that we receive from the sunlight. It comes in a form of photon. So photon, it is the quantum of energy found in light. And because we are talking about energy, so the units for photon is what? Joules. The units for photon is what? Joules. So we have two ways of calculating or determining the photon that comes from electromagnetic radiation. It's either we calculate photon as E is equals to HF, or we can calculate photon as E is equals to HC divided by lambda. So they speak one language, photon. So this is what we are talking about when we are talking about photon. Photon, we can use this equation depending on what we have, or we can use this equation depending on our variable. So that is the topic of the day, photon. It is the packet of energy found in what? In light. So make sure that you sing this definition to your friends, because with definitions, we need to fight to get total. Let's fight to accumulate all the marks. It's 2 marks or nothing. So let's make sure that we win when it comes to definitions. So photon. Photon. It is what? The packet of energy found in what? In light. So we can calculate photon using this equation or using this equation. Let's move on. Let's talk about the penetrating ability of electromagnetic radiation. From our last lesson, we spoke about different frequencies that different types of electromagnetic radiation have. And we did say that it is important that as a grade 10 learner, you must be in a position to do what? To arrange these types of electromagnetic radiation in order of increasing frequency. And we said that gamma ray has the highest frequency. Gamma ray has the highest frequency. And we know that radio wave, it has one of the low frequency. So this is what we are saying. We are saying that now, depending on the frequency that the electromagnetic radiation has, it also affects the way in which it penetrates, more especially our skin as human beings. So electromagnetic radiation that have high frequency, they tend to have a higher ability of penetration to our human skins and cause what? Damage to our skin cells. So different frequencies, they have different degrees of penetration, more especially to our skins. So for an example, as I've mentioned to you, that the human body, it is covered with skin, dead cells that produce what we call melanin. This melanin, it helps us to make sure that some of this radiation does not penetrate inside. So it helps us by making sure that we don't have excessive penetration of electromagnetic radiation. That is the function of the melanin in our skin, is to make sure that we do not have excessive penetration within our skin. So if we are going to have an ultraviolet radiation which has a high frequency, when it penetrates excessively to your skin, it can cause what you call skin damage. As well as the X-ray, when we have excessive penetration of X-ray to our skin, it causes skin damage. So one thing that we need to understand from this statement, it is that electromagnetic radiation with higher frequency will have greater ability of penetration to our skin and cause what? Skin damage. So we can compare their energies, because one thing that we are saying is that if we have a higher frequency, we also have high energy. Photon is directly proportional to the frequency. So it's very important for us to understand that the photon, which is the energy, it is directly proportional to the frequency. So if that electromagnetic radiation, that type of electromagnetic radiation has higher frequency, it tells us that as well it has what? Higher photon. Because when we increase the photon, we are increasing the frequency as well. When we decrease the photon, we are decreasing the frequency as well. So energy is directly proportional to the frequency. So electromagnetic radiation of higher frequencies, they also have higher energy. Let us move on. So I think this is what I was trying to explain. Same thing with electromagnetic radiation that have low frequencies, they will have low energy. So that is why it is important as a grade 10 learner to be in a position to arrange these types of electromagnetic radiation in order of increasing frequency. So we did say that it can cause, because these electromagnetic radiations, they can cause extensive damage, more especially to us as human beings. If they have a higher frequency, they can indeed damage our cells and tissues. For instance, ultraviolet radiation, as much as it has different ranges in frequency, but if we get exposed to excessive ultraviolet radiation, that can cause problems for our skins and damage some parts of our DNA. Right? It is also not good because it does damage the ozone layer. So our skin, how does it respond to that? It develops a brown pigment called melanin. This melanin, it ensures that we do not get an exposure to excessive electromagnetic radiation that can damage us. So melanin, it does protect us from these electromagnetic radiation. There are also other products that we as human beings, we can use because we are indeed innovative to protect ourselves from excessive exposure to electromagnetic radiation. So let's start with this one, X-ray. So the X-ray, we do need the X-ray because it provides an image of our internal environment and the bone structure. So, but it is not important, and also it is not advisable that you go to X-ray scans often. Why? Because you are exposing yourself to X-ray, and excessive exposure to X-ray can cause skin damage. So as much as it is significant to the medical purpose, it is significant to us as well, but we should not expose ourselves excessively to the X-ray because an exposure to X-ray can lead to cell damage, can also cause cancer. It is one of the carcinogens of cancer. Okay, and then gamma ray. Gamma ray, from last lesson we said that the gamma ray, it has the highest frequency. That must tell you something. It has the highest frequency, meaning that it has the highest photon. Being exposed to too much gamma ray, indeed as well, it can create problems to us. It does damage our DNA to some extent. And then we do have microwaves. Cell phones, they do use radio wave as well, which is not harmful to us as human beings because it has low frequency. So radio wave, it has a low frequency. So what is it that I want you to grasp by the end of this lesson? I did say that you should be in a position to define what? Photon. We did say photon. It is the energy packets found in light. That's number one. Number two, we should be in a position to calculate for photon. So now, for us to calculate for the photon, we have equations. But these equations, they involve what we call a Planck's constant, this symbol H. And a Planck's constant is constant. You will be provided with this value from the formula sheet. So what's important as a grade 10 learner, it is to extract it because copying a formula from a formula sheet is a skill. So you must know that this H represents Planck's constant. And the value of the Planck's constant is 6,63 times 10 to the power negative 34 joules per second. So we can have two equations depending on what we have as our scenario. We can calculate the photon as HF, Planck's constant, multiplied by frequency, if we have the value for frequency. We can also calculate for photon as HC divided by lambda, if we have the value for wavelength. So what will influence your decision on choosing the right and relevant equation? It is what you are given and what you are required to calculate. So it is important to understand the scenario. Understand the scenario. Once you understand the scenario, it is going to inform you of the equation that you have to choose. So I have alluded to you that E stands for photon. It is measured in joules. H, it's a Planck's constant, which is 6,63 times 10 to the power negative 34. C is the speed of light, is also constant. It's 3 times 10 to the power 8 meters per second. Frequency, it's represented by symbol F, and it is measured in hertz. Lambda represents wavelength, and it is measured in meters. So let's look at this example. Calculate the energy of photon. That is what the question wants. It requires us to determine the photon with the frequency of 5 times 10 to the power 18 hertz. So the question wants us to determine photon, and we have the frequency. So what do? You choose the relevant equation, which is E is equal to H multiplied by frequency. So what is your photon? You are going to say equal to. Our H is a what? It's a constant, which is our Planck's constant. 6,63 times 10 to the power negative 34, multiplied by the value of the frequency, which is 5 times 10 to the power 18. Then you punch your calculator, you'll get an answer that is 2 times 10 to the power negative 15 joules. So this is your photon. Okay, so you can also respond to these questions. I think I'm going to give you 5 minutes to respond to these questions. Now, I am interested in your response. Let us look at this. Consider the laser pointer and cell phone is shown below. You can see the images of them. State the type of electromagnetic radiation that is emitted by the laser pointer. Usually the laser pointer, you find that when you turn it on, it expresses this red color. So the type of electromagnetic radiation, it can be infrared. For cell phone, we use it for communication. So the type of electromagnetic radiation can be radio wave. Now, a laser pointer uses red light photons. It uses red light photons that have the wavelength of 620 nanometers. We know that nano means times 10 to the power -9. Let's look at this first question. Define the term photon. This one, I'm emphasizing it. Define the term photon. So what is photon? Photon, it is the energy packets found in what? In light. So you need to give yourself 2 marks if you have written that. It's 2 marks or nothing. When we talk about the photon, we are talking about the quantum of energy. That is what photon is. It is the energy packets found in light. So it is important to be in a position to write down this definition. So when we talk about the photon, you must sing it and repeat and repeat and repeat. When we talk about photon, we are talking about the packets of energy found in light. Let's move on. Calculate the energy. So let's calculate for the photon. That's what the question requires us of this red light pointer. So because we have the wavelength, so it means we're going to use this equation that says E is equals to hc divided by lambda, because we have lambda. And then we want E, so we're going to say equal to, what is your h? It's a constant, 6,63 times 10 to the power -34. What is c? It's constant, speed of light, 3 times 10 to the power 8. Then you divide by what? By lambda. So what is your lambda? It's 620. So you should be in a position to write it, times 10 to the power -9. So what's going to be your answer? So you punch it in your calculator and then you'll get your answer. So you are going to say 6,63 times 10 to the power -34 multiplied by 3 times 10 to the power 8 divided by 620 times 10 to the power -9. So I think your answer is going to be 3,2 times 10 to the power -19. And don't forget to put the units, which is joules. So this is what was required from you. Make sure that when you perform a calculation, you write down the correct formula, you substitute correctly. This is what I always emphasize. Write down the correct formula and provide a correct substitution. Refer to the question answered in question 2b. Explain why it is dangerous to shine a laser pointer into the person's eye. This is what we've been saying, the issue of penetration, the degree of penetration. The higher the frequency, the higher the energy, the higher the degree of penetration of that electromagnetic radiation. So if someone points you with an infrared laser and you get an exposure to that in your eye, what's going to happen? It is going to do what? Cause an eye irritation. Furthermore, it can damage your eye and cause temporary blindness or permanent blindness. So that is why it is dangerous to point or to play with the infrared lasers. So here is our answer. Let's move on. Okay, I think this one is an example as well that requires us to look at it. What is the photon? So the question requires us to calculate for this E, photon. of the ultraviolet photon with the wavelength of 200 nanometers. So you look at what you are given. It's very important. You are given the wavelength. So that informs the type of equation that you are going to use, which is E is equals to hc divided by lambda. So we want E. E is equals to H, which is a constant, 6,63 times 10 to the power negative 34. There is no need for you to worry because you will be provided with this constant. Times C, which is 3 times 10 to the power 8, divided by lambda, which is 200 nano, meaning that is 200 times 10 to the power negative 9. And here's your answer, 9,939 times 10 to the power negative 10 joules. Let's move on. Here is another question. Calculate the frequency of ultraviolet radiation shown on the metal surface. The photon of ultraviolet radiation is 7,8 times 10 to the power negative 19 joules. So here it's a problem that we are faced with because I want us to do these calculations over and over again. So the question wants us to determine the frequency. This is what the question wants. It requires us to determine the frequency. But now we are given photon, which is equals to 7,8 times 10 to the power negative 19 joules. So by what you have, it should influence the type of equation that you are going to use. For photon, we are going to say E is equals to HF. E is equals to HF. So write the equation as original as it is. That is very important. Make sure that you write it as original as it is. Then substitute from that equation. So E is equals to 7,8 times 10 to the power negative 19. H is a constant, which is 6,63 times 10 to the power negative 34. We don't know what is our frequency. So it is important to make sure that you write the equation and substitute correct. That's what I'm emphasizing. Make sure that you do that. So when we deal with calculations, we win with writing the correct formula and substituting correctly. And don't tamper with your substitution. It's fine if it means you should repeat it. So you divide both sides by this value. 6,63 times 10 to the power negative 34. 6,63 times 10 to the power negative 34. Then you solve for frequency. They cancel each other. Frequency is equal to. So let's do it together. So you're going to say 7,8 times 10 to the power negative 19 divided by 6,63 times 10 to the power negative 34. And your answer is going to be 1,18. So that's our answer. It's 1,18 times 10 to the power 15 hertz. So this is our answer. Let us move on. And please continue to engage with us on our WhatsApp platform 064 748 8913. Let us engage with this content. I always say this to you that we are a double tech team. So let us deal with this content. Let's deal with this content. So I can give you this as your homework. I'm only interested in number 3. Number 2, you can do it as homework. I'm only interested in number 3. So I want to respond to number 3. A radio program is transmitted in the FM band and it has the wavelength of 3 meters. So we have the radio wave that has the wavelength of 3 meters. So the question requires us to calculate for the energy of photon. But what is it that we have? We have the wavelength, which is what? 3 meters. So this influences the type of equation that we are going to have. It influences the type of equation that we are going to have. So we are going to say E is equals to HC divided by what? by lambda equals to, what is your h? It's a constant, 6,63 times 10 to the power negative 34. What is your c? What is your c? It is 3 times 10 to the power 8 divided by 3 meter, which is our wavelength. So what is going to be our answer? 6,63 times 10 to the power negative 34 multiplied by 3 times 10 to the power 8 divided by 3. So our answer is going to be 6,63 times 10 to the power negative 26 what? Joules. So this is our answer. This is our answer. Let's move on. Let's move on. So this can also be your homework, where you write down the type of radiation that is used. You can see it's an X-ray. And the dangers of X-ray, it can cause cancer. So this is what I've been saying, that no, it is important to know it, right? When you talk about electromagnetic radiation, it has this special property that it acts as both particle and a wave. And the speed of the light is 3 times 10 to the power 8 meters per second. And the light can also travel in the vacuum. So that is also important. We did say that it possesses these special properties, that the light has a huge spectrum, okay? But we can only detect, or we are sensitive to only a minute spectrum, which is the one for visible light. But light itself, it has a huge spectrum. It can travel in a vacuum without a medium. It does travel in a medium, but it can also travel in a vacuum. And the speed of the light, it's very, very fast. Light travels faster than we think. 3 times 10 to the power 8. You can imagine 8 zeros. That is how fast the light travels in 1 second. Okay, so we do have different types of electromagnetic radiation. It can be radio wave, microwave, infrared, ultraviolet, X-ray, and gamma ray. And I am saying to you that as a grade 10 learner, you should be in a position to arrange these types of electromagnetic radiation according to their order of increasing frequency. And we are saying that radio wave has the lowest frequency. Gamma ray has the highest frequency. And from this equation, E is equals to HF, it tells us that energy of photon is directly proportional to frequency. So an electromagnetic radiation that has low frequency, it also possesses low energy of photon. An electromagnetic radiation that has high frequency, it also possesses high energy of photon. So we are saying that gamma ray has the most energy and it is most penetrating. It has the most energy. It is most penetrating. Why are we saying that? It is because it has the highest frequency. Gamma ray has the highest frequency. So because it has the highest frequency, it's going to have the highest energy and it's going to have the highest degree of penetration. So these are the units of quantities that we use to determine the known. So it's very important to also familiarize yourself with this. So before I finish this lesson, let us look at your WhatsApp comments. Let us engage with this knowledge. Physical sciences should be our everyday language. It should be our topic for the day. So we should continue to engage with this content. Let's look at WhatsApp platform. What is it that people are saying on our WhatsApp platform? There was a question. I think, okay, this one. So we did receive something from Koketso, and he was asking us what is light photon. So that is very important. What is a light photon? You have asked a fundamental question. What is a light photon? So when we talk about photon, we are talking about energy packets found in light. That is what the photon is. It is the quantum of energy found in light. So when we receive the sunlight, typical example from the sun, that radiation from the sun, we need it. Why? Because it gives us energy. It keeps us warm as well. So when that energy strikes us as living organisms, it comes with packets of energy. So we tend to also gain that energy, which is what? Photon. So when we talk about photon, it is energy packets of light. That is very important. So it is the energy packets found in that is very important. When we talk about photon, we are talking about the energy that is found in light, because electromagnetic radiation has to do with light. So that energy, it comes in packets. That is what a photon is. It is the quantum of energy found in light. And we are saying this, okay, so that let us emphasize these definitions. Let's sing them and make sure that we know them, because we cannot afford to lose these marks. We cannot afford to lose these 2 marks. So when we talk about photon, we are talking about the packet of energy found in light. So ladies and gentlemen, let us continue. Let us continue to engage. Let this conversation not end. It should never end. We should always have physics conversations. I thank you. See you next time. I thank you. I thank you. I thank you.